So at this point, I'm going to show you how to do it from the slide, sort of. So here's the second way of slicing, right? So the second way of slicing basically here is I'm now going to use the command value count. You guys remember that, right? When I showed you how to use value counts. As a recap, I'll show you. So candidate name dot value counts. All right. I have the value counts. The value counts basically gives me the unique values and all the amount of and the frequency of those values within the column, or the time, how many iterations there are within the column. All right. So that basically has the candidate names that I want. So what I can do is I can actually save this as NYC df2. Process this, and now my students on Spider, you're going to notice something. NYC df2, I'll double click on it. It's a series, right? It's a series right here. It's saying it's a series. The value count, and subsequently later on, you guys are going to see in the group by, the output of these functions is literally a series. So when I click on this, it's a series, right? You have the index, the names are actually the index, the frequency of the row of those names in the column is under the candidate underscore name column. Why candidate underscore name column? Because that's technically what you did the value counts on. So that's why it stuck that column with the candidate underscore name column name. All right, if I were to type this in NYCDF2 in here, okay, it looks like that. Okay, now, given this, oh, by the way, for my students that aren't on Spider, I'm going to show you a nifty little function that you will use a lot. I use this all the time, called str. And what str does is it's the equivalent of the class function in R, right? For my ABI students, if you remember, the class function tells you what kind of data container you're dealing with. That's what str does here. If I type in nycdf2 in here, it's literally telling you, oops, what happened there? Oh, I'm sorry, not str. It's type. This is the function, guys, type type. I have it in my slides right here in line 3. I'm losing my mind. I type that, and it literally tells you what it is. It's a series. NYCDF2 as currently is a series. Okay, so how do we deal with this? Well, one way to deal with this. Remember, I have the values I want are in the index, and the iterations are under the wrong column. So how do I deal with this? I'm going to show you a nifty little function called dot reset index. All right. Now this is cool in the sense that when you this is going to overwrite NYCDF2. When you do this, now my students notice what is NYCDF2 now. What type is it? It's now a data frame. Let's click on it and look at it. What's going on? Okay. So what happened was candidate name column is still there. Fine. But the original index is now lowercase, and you can't tell from the video, but what's happening here is it's actually now a column name. What reset index did was it took the existing index and made it into a column of values and gave it the name index with a lowercase I. The reset index also created a whole new index for the table, for the series. Well, now it's a Pandas table. With the default indexes starting with 0 as an integer and just incrementing it by 1. Now, why did this become a Pandas table? What ended up happening is because it turned the original indexes into a new column, there's no longer just one value in the series. There's two. Series can only have one value. It cannot have more than one. Because we forced it to have two, it automatically converted itself into a Pandas data frame. So now candidate name was a series, lowercase I index is a series, and now it has an index of integers. That's what reset index did. Now, what we need to do is we need to delete this column because we don't even need it, the candidate underscore name column. But we need to rename this lowercase I index column into candidate underscore name because that's the right name. So how do we do the first step? How do we delete a column, guys? You already know this technically. From our intro slides, the del keyword. And what you're going to do is you're going to give it the column name that you want to delete. In this case, I want to delete the column, the current candidate underscore name. I do this, and we can click on NYCDF2 again, and notice it's still one column. Now we have, it's back to one column, but it stays as a table. It stays as a data frame. It does not go back to being series. It stays as a data frame. Once it's upgraded to a data frame, it stays there. So now all that's left is for me to rename that column. How do I rename the column? So this, I will use NYCDF2. And this will now become, now look, notice something. I just have one column. Even though I'm just updating one column, I only have one column, I still have to provide the name, the new name of the column in a list. And that's why I have a list there. All right. Also notice that if you had, let's say, 5 columns, you would have to, if you're overwriting the column names, using this particular technique, you have to pretty much overwrite all the column names, right? I'll show you later how to overwrite a single column, but this requires us to overwrite all the column names, okay? Using this methodology right here. All right, now I click on this, and you'll see that I have the right candidate name. Excellent, excellent, right? And from this point, guys, all I would have to do is now execute the lines of code from 74 to 78 on the DF2 table now, on the NYC DF2 table, line 74, 78, and now I'm good to go. And finally, the third way, and this is exactly like our the slides. Third way to do this, and again, I'm showing you these different ways just so you guys have a better understanding of the little nuances and the little tricks you have at your disposal using Pandas. So in my slides now, right, we use value counts again. So let me use value counts again, right? And this time I'll call it something called DFC, and I do that for a reason. Right? You guys know this creates a series. Now, in our series, you guys know that you have those values and index properties. So the values are what? Okay, the values gives you an array of literally the iterations. We know this. The values is not going to do anything for us. What we want is in the indexes, right? But when I type an index, you notice you get an index object back. Now, before when we did this for a numeric index, you got that range index object. In this case, you get a simple index object. It's still an index object. It's not an array, but it's an index object. And it has the values we want. How do we get our hands on those values, those alphanumeric values? Well, the index property, when it's an alphanumeric, has its own values property. And when I click on this, now you will see that you have those values back as an array. And so this we will store in a data container as a NumPy array. And guess what? We're going to use it as a new table, using that array. And like I said before, you can create an array with a list from a NumPy array or from a series. It doesn't matter. It's a very versatile data frame. So here we're going to create a new table from that array. And this is exactly what I do on my slide. I do this, click on NYCDF3 up here, boom. And now we have the table, unique values and tables, right? And now that looks exactly like this table, and just like this table, all you need to do now in NYCDF3 is execute these lines of codes on it, and now both that table too will look exactly like this table. All right. So now we're ready to go. Now we're ready to go and use and create our dictionary. Now, hold on. Excellent. So we're going to create a dictionary using that table. That's little mini table we created. We made. We're going to create a dictionary. Now, why are we creating a dictionary? Firstly, what is a dictionary? Let's start there. So a dictionary for my new programmers is I'm gonna call this x_dict for dictionary. The syntax for a dictionary is very simple. First of all, the dictionary is a type of object that is a hangover from the old days of programming. It's something we technically don't need anymore with a lot of these new languages, but it's still there because it still has a benefits. In a case like this, it has like in a case like this, right? There's a benefit to having a dictionary, using a dictionary. Now, here's an example of a dictionary if I write it, a very simple one. A dictionary is basically a pairing of keys and values, right? The key will always have to be unique, but you can have as many values as you want. So, but in this case, I'm going to keep it simple. There will be 3 keys, one that's A, one that's B with the value. So A has a value 3 associated with it. The key B has a value 10, and the key C has a value associated with 20 with it, right? I go ahead and execute this, and ladies and gentlemen, I have a dictionary, right? If I were to type this in, you see that it has these unique pairings right here. Okay, so how do I use this? Well, if I simply type in the key, it gives me the value. So A will give me 3, B will give me 10, etc., etc., etc. Now, right off the bat, I'm sure you guys can see, listen, why do we need this? We have the series. The series, we can just create an alphanumeric index for a series with the appropriate values, and it has the same, and we can use it the same way. We're good to go. Yeah, pretty much, right? Nevertheless, it's still there in our programmings, in our different programming languages, and we can use it. So this is a dictionary. That's technically how you write it. And over here, we're going to create a dictionary from our small unique table where the candidate name is the key and the party is the value. See that? The candidate name is the key and the party is the value. And the reason we're doing this is because when we map this dictionary to our big table, the candidate's name in the candidate_name columns, they will serve as the keys, right, to these dictionaries and get the value back for us, right? That's basically what's going to happen. That's how it works, right? That's basically how it's going to work. Now, how do we create a dictionary? Well, we use 2 functions to pretty much create a dictionary. First, we use a function called dict that stands for dictionary. That makes sense. What does not make sense in the world of Python is the zip function. The zip function, basically, you're specifying the 2 columns that you want in their key value pairing in that order. The first column is the key, the second column is the value. And then you're passing that to the dictionary function. It's very weird if you use the zip function, right, by itself. Like let me create a variable called z that will hold hold the results from the zip function. And like I said before, the first column will be the key, what should be the key. In this case, it's going to be candidate_name. And the second one will be and the second one will be the values. In this case, it will be the party. All right. So execute this. Oop. I got an error. Hold on a second. Sorry, I have an extra bracket in here. That's what happened. All right, excellent. Why do I have... Oh, sorry. The reason I had a bracket because I wasn't paying attention. There. So close that bracket. Close that bracket. Excellent. No more error. All right, perfect. Now if I type in Z, you'll notice you have a weird zip object. What is this? I have no idea, right? Nevertheless, this is how the dict function works. So when I create the function now for candidates, I'll call it candidate_dict. And now I use the dict function, the dictionary function. I simply can just write that in line 98 in, or just put Z right in there. Process that, and there we are, candidate_dictionary, right? If I click on it right here, you'll notice that it has the keys right there for you. It has the values right there, and it tells you what the type of the value is. What's the type for the value? The value is literally a string, right? Nice and easy. If I go down here and I just process it, and it looks like just like my slides, right? Looks just like my slides. So now I have my dictionary, and I'm ready to go. So how am I going to use the dictionary to update my values? Well, I took my original column. I'll call the new column party. I'll call it all caps because that's what I do in my slides. Just keep it consistent. And now what I need to do is, let's say hypothetically, first off, in my original table, because I'm not slicing or dicing, I'm doing it on the whole column, I don't need to use LOC or iLock. I could do it directly in the data container without iLock or lock. Now, if I just did this, right, what would end up happening is a new column called party would be created, and in that column, for each row, the value chocolate would be there, right? So that's basically how that syntax works. Now, in this case, I want to use the dictionary to create the new the values for the party. So first thing I want to do is, like I said before, I need to specify what the keys will be, and the keys are going to be my candidate names, right? And these candidate names will be sent as keys to the candidate underscore dictionary, right? Unfortunately, I don't know why that's not happening, but it's not, the map should be a different color. I don't know why it's not a different color. But anyway, it doesn't matter. So basically what happens is, so let's take the example, the first row will probably have the name Hillary Clinton. So the first row for candidate underscore name will be Hillary Clinton, right? Or Clinton, comma, Hillary Rodham, whatever. That name will be passed into this dictionary, okay, as a key. That key will give us that key, for giving that key to the candidate underscore dictionary, will give us the value Democrat. That value Democrat is then given to this column for that row, and that's how that value Democrat gets there. And it keeps happening row by row by row. Now watch how fast this executes for all 600,000 rows. Pretty fast, huh? Pretty fast. And now I have my candidate, my party affiliations. I updated real quick. Now, if I didn't do it like that, right? If I didn't do it, now why am I doing it like this? It's just so much more faster. I mean, it's not just faster, but it's so much more cleaner and easier. If I didn't do it this way, if I went back and started doing it applying the same logic from, let's say, line 78, right? When I was updating the Republican parties, but instead I do it to the big table. So then I would basically have to do dot lock, right, comma, party equals Democrat, right? So this part you guys should be comfortable with, this part of the syntax. Here now I would have to put another kind of logical check like we did before. And in this case, it would be basically, let me do it out here and I'll bring it back in there. So it would be basically, how do I create a logical check here? I do NYC candidate name equal, oh shoot, let me just copy this, long name. All right. Now, first of all, my students, notice this is a double equals, not a single equals. A single equals means you're creating or updating an existing data container. So here, my students, this be a double equals. What does a double equals mean? A double equals basically is a logical command. It's basically asking, hey, are these two things equivalent? Double equals means equivalence. Is it the same value? Is it the same value? So what's happening here is, if I execute this, all right, what's happening here is, it's checking to see if every value in this column is equivalent to this value. Where that is the case, you'll get a true. Where it's not the case, you'll get a false. Does this remind you of something? This is exactly what we did in line. This is the whole, this is the Boolean filtering or the logical filtering that we did in line 78 when we updated the values of the small table, right? And so if I take this, copy it in here, put it in here, exactly like that, right? This right here to the left of the comma, again to the left of the comma, is creating true and falses. And LOC will take all the trues and grab their index values. And wherever it's false, it will totally ignore those index values. So what ends up happening here is here, you end up updating all the Hillary values, that are going to be true, to the value Democrat. Now, that's fantastic, but I would have to keep doing this for each candidate, right? Granted, I have like what? I don't know, 20, 25 candidates? What if I had 250? I'm not doing this 250 times. This is the superiority of doing it this way. We did one line, clean, concise. Once you have the dictionary and the mappings, just use it. Boom, done, and it updates it. That's the power behind it. Cool? So that's basically it works. And now we can basically confirm that it does work. I want to basically see the first, let's say 10 rows of just those two columns. Now, if I wanted to see the first 10 rows of one particular column, you guys know how to do that, right? If I do candidate underscore name, I showed you the head function already. Done. See that? But I want to see two columns. How do I do that? Okay, some of you guys might be saying, oh, cool, just do candidate name, comma, and the party, right? Error. Oh, first of all, what the hell's party? It's party. All right, let me do it again. Error. Why is that an error, guys? I showed you guys that before. Can't put a comma in the double brackets, and I'm in the single brackets, but there's a way to do this. And the hint here is line 74. See how in line 74 to the left of the comma, we put those extra values in, those more than one values in the additional square brackets? Same concept. So if I want to see more than one column, or select more than one column, I must then start putting it in double brackets, like that. And when I execute this, then you guys can see that, okay, cool, yeah. I have the candidate's name, Democrat, Bernie's a Democrat, I got a little Donald Trump there as a Republican, right? Fantastic. So I know this worked. Excellent. And now we're done with number one. All right, number two. Number two involves us, remember we have that column, CONTB underscore received date. That's basically the date of each donation. And if you remember, it was as an object, not a date. It was an object, meaning a string or alphanumeric. It wasn't stored as a date. We now want to create, we now want to create a new column that will be the date equivalent of that, right? We don't want to overwrite the existing one because we just leave it there, but I want to create a new one that's a date equivalent. And this is, and first of all, I don't have to tell you guys why that's important. You need that when you have a time series, right? Because you're going to see later on where that comes into play, and it makes things a lot easier for us. So my first point I want to make is that Pandas has a really cool function for this. Now, I knock Pandas and Python all the time, right? My true love is R, obviously. But even though I use Python more probably in terms of work, yeah, I probably use Python more. So there's a really cool function here in the Pandas packages called to_datetime, which is awesome. What to_datetime does, so this is the original date of that column, right? Notice the format, the 15th, April 16th, right? Day, 3-letter month, 2-digit year. Okay? Now, that's the format. This to_datetime function works great in the sense that it figures out what the format is of these strings, right? It'll go in and say, okay, this is the day, this is the month, here is the year. It figures it out for you. Now, I've worked with data sets where the column that represents a date, first of all, it's not as a date, it's not a data object, but even worse, the values in that column are in different formats. They're different date formats, right? It's a nightmare. it does not matter with the 2_ datetime function. The 2_ datetime function figures out automatically what is the format of the date, what are the right date values, and converts it into a date. So they'll all be, no matter what the format is, turn into this right here. Turn into this right here. And by the way, this is the format for dates in Pandas, YYY-MM-DD. The same format as an R, which is fantastic that they actually do keep that they do keep that consistent. YYY-MM-DD. Right? So to use this function, it's very easy. You simply, first off, the new column I'm creating, NYC. We'll create a new column for this. Date. I don't know why I'm doing lowercase. I should have done everything uppercase, but whatever. PD dot 2_datetime. and then the column that's going to convert it into a date. And because I have to copy and paste it, I don't like typing in the column names because I always make a mistake. So I will just go ahead and run the nyc.d types again. Right? Because remember, I showed you guys this function. It shows you the structure of the table. This just allows me to copy and paste. Copy, paste. I go ahead and run this. And by the way, when I run this, I will pause because this will take 45 seconds to run on my machine. It might take on your machine a few minutes to run. So here I kick it off, and you see it's taking a while. And the reason it's taking a while to do this because, like I said, it needs to go to every element and dissect it and figure out what's the format it's in and dissect it so that it can make the appropriate years, months, and days. All right, so I'll quickly pause this. And to the magic of Hollywood, it is done. So for me, it took about 30-40 seconds. I have a powerful laptop. Some of you guys might take a few minutes, right? And now, just like before, we can go ahead and view the results. I run this, and it's bigger over here. And you can see now I have these results. Fantastic. All right. Question number 3. Yes. So question number 3 requires us to now learn the group by feature and functionality. All right. The group by feature and functionality is very powerful. I use it all the time. And allows you to take a summary of the data. Okay. This is equivalent to your pivot tables in Excel, or for any of you guys have done SQL. If you haven't, please make sure you take an MIS or database class. But it's the equivalent of group by in SQL. Same thing, right? Where you're trying to aggregate your values. You're trying to take an average or aggregate the values according to some sort of mathematical transformation, right? So here's a simple example. Let's say we have a series A with the values red, blue, yellow, orange, red, blue, and yellow, orange. You have a series B that's just 1, 1, 1, 2, 2, 2. And you have a series price. That's just what values is this going to be, guys? It's just going to be the range from 1 to 9, excluding 9. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then we create a table called DFEXMP from those 3 columns. And this is why you see this table right before you. Column A, B, price, and these values. Okay? All right. From here, let's say I ask you now that I want the sum of all the prices according to each color in column A. So I want the summation of all the prices of red, all the prices of blue, all the prices of yellow, and all the prices of orange. Okay? How do I do this? Group by. I use the group by feature to do this. The first step is to actually literally write the function .groupby. You do dfexmp, the name of the table, .groupby. And because it's a function, within the parentheses, you specify the column that you want to aggregate, that you want to do the aggregation on. In our case, like I said before, we are doing an aggregation on column A because I basically want a summary right? I want a summary on column A, but I want a summary of the prices for column A. Okay, that's basically what's happening. I want a summary of the prices according to column A. So whatever column is the summary is the summary or the grouping happening according to, that is what goes into the group by. Now behind the scenes, once you specify group by A, once you specify the column, right, then what happens is subtables are created. You don't see this. This happens behind the scenes in the memory, right? And a subtable is created for every unique value in that column. So because we have 4 unique values in column A, red, blue, yellow, and orange, 4 unique subtables are created. All right, so that's step 1. Figuring out which column you want to basically have the groupings by. You want to have the groupings by. After that, then after you have the subtables, the next step is to select the columns within the subtable that you want to have some sort of summary that you want to summarize. Okay? In our case, we want to summarize the prices according to the colors. We want to summarize the prices according to the colors, right? Basically the summation. So this is where our syntax falls backwards back into our syntax in our Pandas syntax, right? So the group by function is a strange one-off, and then from there, the group by, that creates the subtables, and then from there now, you're now selecting the column within each subtable. So here where I'm selecting the column price, that column is being selected in each one of the subtables created by the grouping of column A. Basically finding the unique values of column A, creating all the subtables for it. And now the last step is simply creating the sum. Simply executing the sum. Basically saying dot and the function you want. In this case, I want the function sum. And this is why we end up with, in each subtable, it collapses according to the transformation or the aggregation you want, sum. So we get red 6, blue 8, yellow 10, orange 12. It then stacks them back up and gives you the results back. Okay? The results come back at you, one, as a series, right? Just like I said before. Value counts gives you a series, that's a function. All the group by commands gives you series as well. All right? So you get the series back. And the ordering will be in alphabetical order or numerical order according to the column you use to do the grouping. Because we used A to do the grouping, the subtables were created according to A, and the results will come back according to the titles of those subtables, in this case, alphabetical order. And that's why we have blue, orange, red, and yellow. Okay? That's why we have it come back in that value. So let me quickly knock this out. Let me quickly do this real quick. So red, blue, yellow, orange. I know that would be a nightmare. So I'll put this all under number 3. So A is, God's sake, red, blue, yellow, orange. Okay, I don't know what's happening here. My computer's slowing down. Copy this. Scroll over. Excellent. A is good. All right, the rest of B should be faster now. B. Close that space. Close that space. And close that space. Now I'll make a table. All right, now the DFDX table, and now I'll do the grouping by that I did before. I'll show you guys do that step by step again. Choose the column price and do dot sum. You run it and see the results. Let me go ahead and store this in a variable D so you guys can see what's going on here. All right, and D, if I run type on D, you guys see that it's a series. It's a series, like I said before, it's a series. Okay, so it comes back anytime you use group by the way, the object you get back is always a series. It's always a series. This comes into play a little bit later. All right, so now let's jump into actual number 3, what we actually wanted to do. For number 3, we wanted to calculate the amount of donations, the count of donations, the frequency of donations made to each party. Not the total summation, right? Not the total dollar amount, but the amount, the count, how much they were given to each party. Okay, so here, which column do I want to basically get the summary of? I'm getting the summary of the column of the parties, right? That's where I'm getting a summary of. I want to summarize something about the parties. That is why, ignore that red dot. I don't know why this red dot's here. I downloaded Kite with my spider. I think that was a huge mistake. It's just, I have boxes constantly popping up now, serving me. I gotta somehow figure out how to shut off Kite now. So do NYC, right, dot group by. All right, and then which column is it that I want to summarize? I want to summarize the party, right? And what kind of summary do I want from the party? Well, in this case, I want to know the total amount of donations made to each party. I could really select any column I want, but I know that I'm going to use this column later on. Here, let me do NYCD types again. So I know I'm going to use this column later on. CONTB receipt amount. This is the amount of the, this column has the amount of the donation made. I'm going to use it a little bit later, so I'll use it right now. So that's the column that I want highlighted in each one of those subtables. So there's going to be a subtable for Republicans, Democrats, Independents, etc. This column will be highlighted in those columns. Now, what do I want to do with transformation? What aggregation do I want to do? I want to count. And when I do this, I get the nice result. See that? I get the total count of how many donations were made to Democrats, how many donations were made to the Green Party, how many to the Independents, etc., etc. Okay. Also, if you recall, I can simply also use that. Can't write. I can also just use the value counts. Look at that, huh? It's almost the same. The results are the same, but the ordering is different. The reason why the ordering is different is because value count, if you recall, gives you the values in descending order according to the count. Whereas the group by gives you the values back according to the column's alphabetical orders, right? According to the column's alphabetical order, right? And that's why you have Democrat here. Democrat, Green, Independent, Libertarian. That's why you tend to have that. All right? So that's basically what's happening there. All right. Next question, question number 4. So number 4 is kind of the same, except now I want to know how many donations were made to each party on each date. How many donations were made to each party on each date? Okay, cool. So this is also a group by question, guys. This is also a group by question. The difference here is that now I need to know not just how many donations were made to each party. So basically, I don't. It's not that I just need a party subtable, but I need a subtable for each party's and its date. Okay. So for example, up here, the Democrats on this date got 3 donations, right? So I need a subtable that's separated by both Democrat and the date. And that is why in the group by up here now, you will see that I'm not grouping by just one column, I'm grouping by 2 columns. How does this work? Very simple. Each column has a unique amount of values. Let's say hypothetically, we have a lot of dates here. Let's say hypothetically, the party has 5 unique parties, Republican, Democrats, and whoever the other people are. The date column has only 2 unique dates, Halloween and Christmas, October 31st, December 25th. Right? Let's say those are only 2 dates, right? The way this works is the unique values of one column times the unique values of the second column gives you the number of all the subtables. So in my example I'm giving you, we would have 10 subtables. We would have a subtable for Democrats on Christmas, on the Christmas day, Democrats on Halloween, Republicans on Christmas, Republicans on Halloween, Independents and Christmas, Independents and Halloween, etc., etc., etc. So we'll have 2 subtables. In this case, we'll have lots of subtables because we have many, many dates, right? So each party and each particular date will have its own individual subtable. Everything after that is the same. Now notice when I put more than one column in the group by, I gotta put those square brackets again. Just like here, where were we? Just like here in line 105, right? When I have more than one column name I'm selecting, I have to put in extra square brackets, right? There's those square brackets again when we select more than one column. You see a theme coming here, guys? When you select more than one column, you have to use the square brackets. For my ABI students, this is equivalent to when we select more than one column or more than one any value, and we have to use the C function. Same things coming into play. Same things happening, guys. Right? So that's basically what's happening here. So everything else is the same. Contribution receipt amount and count. Done. Let's do it. So number 4, take this. And as you can see, I got a lot of values. That's why you have the dot dot. And now you can see the Democrats on this day had 3 donations. This day had that donations. And now notice, by the way, it's done first. Notice the ordering. It's party first, then date. Why? Because this is the order. This is the order. Now I want to show you something. If I do D equals, again, I'll store it in the D container, and I run this, what does D say up here that it is, my spider students? A series. A series. My Jupyter students type in type D, right? It's a series. But how could that be? Let's click on D for a second. How could this be? There's 3 columns there. No, there aren't 3 columns. There's the values, the CONTB underscore receipt amount, the count pretty much, those values. And there's 2 indexes. That's right, 2 indexes. This is called multi-indexes, guys. Multi-indexes, right? Let me show you. D dot values gives you the values. You have an array of the values, right? A lot of them. But when you type in D dot index, look what you get. You get something strange. Scroll all the way up, if you can. I can, so I did it. And literally, the first thing when you type in d.index, the first thing that comes out is called multi-index. And then there's a parenthesis, then there's levels with the party affiliations, and there's a comma, and then there's another list of dates, etc., etc. There's a whole bunch of stuff going on there. Multi-indexes is more advanced pandas. We're not going to get into that this semester, right? Remember, this is an intro class, guys. This is from the beginning, right? Very powerful. You can do a lot of crazy things with it. I keep it simple here, right? But it's very powerful multi-indexes. So that's basically what happens. You're using group by, you still get a series back, but in this case, right? But in this case, you still get a series back, but in this case, you're getting a series with multi-indexes, the party and dates, All right. Now, another thing I want to show you. Let's say I take this, and now let's say hypothetically, instead of using the date column, I use where are you? This original column, our original column that was stored as a string. That works fine, but look at the ordering now. April 2016, August 2015, August 2016, December 2015. What the heck is happening? What's happening here is it's coming back as alphabetical order. Not chronological, but alphabetical. Why? Because to Pandas, that is merely a string. Pandas has no idea that that's a data object. All right? Also, we can flip the ordering of the indexes, meaning I don't have to have party first. I can have date first, then party. All right, date first, then party. And look what happens. Now you have it according to dates first and then the party. So it looks like 2 Republicans gave in October 10th. No, October 10th. 2 Republicans gave ideally in October 2013 for the 2016 election cycle. Jump on it. 2014, one gave. 2014, one gave. 2014, another gave, etc., etc. Democrats are on the board in November of 2014, 3 of them. So it breaks it down like this, right? Sometimes it's even more intuitive. Sometimes more intuitive. All right, so that is number 4. Jumping to number 5. What is this error saying? Pie flakes. God. All right, number 5. Now, number 5 is now I'm asking you, okay, how much money did each party make on the donations? Yeah, I'm using make, right? We all know this is a big scam, right? So how much money did each party make? Okay, this, I had the foresight to use the right column, right? So this again is, let me go ahead and grab this. It's basically my number 3, guys. It's basically my number 3. I want to basically, I want to know something, I want to summarize something about the parties, right? The party column. But the summary I want involves summarizing the donation amounts given, and the actual summary I want the summation. I want to sum them all up. I want to know the total amount given to each party. When I execute this, I get in this case, in this case I did it twice. All right, so that's a shame. So what happens here is I get the results back as 2 decimal place numbers. If I didn't, ideally, this is how you should get it back. It's because I pre-ran the formats. But let me tell you what's happening. When you guys run this is what you guys see. You guys see scientific notation. I don't know what the hell that means. Some of you guys might be math majors. You're like, yes, perfect, sounds great. Lovely, right? For the rest of us human beings, we don't know what that is. Enter a nice little trick. And I'm not going to test you guys on this. This is for your personal benefit because I have to do this all the time because I'm always dealing with data from large problem sets, large data sets, right? So here, I am going to change the options of how floats are seen. So literally, you go to PD, remember, which is the variable that represents pandas. You go to dot options. So it's like you're clicking on a menu. You go to options in that package. You go to display within that options, and then you go to the float underscore format within display. All right, let's copy that. Just get the underscore there. And the format that I want to do is I get this weird thing. This is very strange. I'll try to make sense of it for you. Okay, within the quotes and squiggly braces, there's a comma, right? To the left of the comma, you are specifying how many of the whole numbers you want to see. In this case, I want to see all of them. That's why we put colon. Remember, colon technically means all. All right. To the right, we're specifying how many decimal places we want. In this case, I want a decimal place of 2, right? And you got to put the F afterwards, again, to re-emphasize the fact that it's a float. If I wanted 3, I would just put 3 in there. If I wanted 4, I would put 4 in there, and so on, so on, so on. Okay? Close the quote. Dot format. This will convert this into whatever format object float format is looking for. And when you execute this, right, you'll now get the results the way I see them right now. Nice dollar amounts, right? And from here, ladies and gentlemen, you can see the Democrats housed $153 million. $153 million to lose an election that they should have easily have won. All right? That's what we call buyer's remorse. It makes you think twice about donating to some of these parties, right? To some of these candidates. All right, jump to number 6. And guys, in number 6, what is it? In number 6, I'm doing the same game again. I'm saying, listen, give me the party's sum of donation by date. So basically, how much did each party get or make on each day? So now this is basically my question number 5. No, I'm sorry, my question number 4. Okay. And it's exactly the same. I'm creating subtables by date and party. I want to, and I want to take now not a count of the column, the contribution amount column, but I want the summation. I want to sum up the contribution receipt amount according to each date and party, right? According to each date and party. And that's why I get this nice result right here. Oh, sorry, let's do party and date first. Keep it consistent. That's how we get this nice results like this. Right, Democrats, 7,000, 5,000. Whoa, 240,000, 5,000. Very nice. All right, and we can also flip it like I did before. Okay. And we can see now the first donation made on what we originally saw on October of 2013 for Republicans. It was $0, man. It was $0. It looks like, no, remember, this is the aggregation, right? This total amount. So it looked like possibly somebody donated and then they weren't supposed to donate or something and took a refund or something like that. In some cases, you see like negative numbers here. Why do we have negative numbers? Again, people could have been like taking, I mean, for whatever reason, they probably donated off the credit card and the campaigns mistakenly charged twice or extra. Yeah, right. And they asked for a refund or some other shady tax stuff going on. Who knows? You know these people. These people. Right? And so here we go. We have the different answers we want. Again, everything's coming back as a series. In this case, it's a multi-index series. All right, number 7. All right. Now, what I want to do here is for number 7 is I want to get the top 5 donors by occupation. Okay? The top 5 donors by occupation. So basically, what do I want? I want to basically take the occupation column, right, which is the CONTVR_occupation column, and I want to basically aggregate it to see what's the total amount each occupation donated, and I just want to see the top 5. In that case, I want to see the top 5. I'm going to do this 2 different ways. All right, I'm going to do this 2 different ways. Okay, because I want, again, the top 5. Right. So firstly, actually, am I going to do 2 different ways? Yeah, I'm going to do 2 different ways here for number 7. Okay, so firstly, what I'm going to do is I'm going to do my group by. Where are you? column names. Done. I got my column names there. And like I said before, I know I have my occupation right there, right? And if you're not sure, remember we can always look at the individual row like we did before. Just one row of a table, a Pandas table, comes back as a series going downward, so we could always identify what the right column is. In this case, I know this is the right column. So I want to do this group by. All right, and I'm going to select this column as well. And I'm going to take the sum of it. All right. Sweet. I got the results I need. Look at that. Sweet. All right. All these contribution amounts aggregated. All right. Now, this is great, but I need to store it. I need to store it so I can mess around with it. So I'm going to store it as something called df7. Okay. So df7. Remember, df7 right now is a series. df7 is right now a series. Now, what I want to do is, remember, I want the top 5. Okay. So how do I get the top 5? I need to do the ordering of it. So how do I do the ordering? Well, for df7, because it's a series, I can do df. And now I'm going a little different from my slides again, right? Because I'm showing you 2 different ways. The function name is sort values, right? Sort values. By default, this will sort it in ascending order. But it'll only do it temporarily. Like if I sort it, you can't see it, but it's coming out ascending order, okay? And you can't see this. You won't be able to notice this. This is how we sort, by the way, a series. If I want to permanently change the sorting order of the series, then I would have to use a keyword in here called inPlace equals true. And what this will do, guys, is this will permanently change df7 to be sorted in ascending order. Now again, it's ascending order, but I want descending order. So how do I do descending? The way you sort descending is you do another parameter. We can put that parameter before. You can put it before or after. It doesn't really matter, right? But you just have to label it. And it's literally, you type in ascending equals false. Now, if I type in df7, it's in descending order, right? Why ascending equal false instead of descending equal true? I have no idea. That's the only keyword for sort values, ascending. By default, it's true. So if you want descending, you have to do ascending equals false. Now, I'm going to warn you, for the finals, I once gave a question where I had descending equals true and all this other stuff. 90% of the students got that wrong. They started checking off the descending. There is no descending parameter. Don't make that mistake, all right? It's ascending equals false, or if you don't do anything, it's by default ascending is equals true. Don't make that mistake, all right? So here, df7, if I do, what did I say for my slides? I wanted the top 5 donors. Boom. I now have my top 5 donors. Retired, that's code for rich, old and rich. Attorney, that's a lawyer. Information requested, they didn't want to say anything. Lawyer, that's an attorney. Not employed, that's code for rich. All right. So my ABI students, you notice something, right? Why is attorney and lawyer there twice? We should have fixed this. So I apologize. We should have. We just don't have time. But before we're doing this analysis, we should do what we call do a little data fixing or data wrangling. Do exploratory analysis on the data and see where there's inconsistencies like this and change and fix it so we get better results, right? In this case, it's all right. We're just going to roll with it. So this is one way to do it. Another way to do it, and this is the way I did in my slides, right? So here, I'm going to do or. Here now, I have df7, right? And I just jumped in and I did sort values. Fine. But after I did the df7, in my slides I did it in 1 line, but here I'll do it in 2 lines. I then did df7 equals df7 dot reset index. Do you guys remember what this does? Reset index basically takes the existing index, makes it a new column name, and creates a whole new index. In this case, df7, the values are the values, and the CONTB, the actual occupation names are the index. So when I do this now, and when you type in df7 dot head, let's say 10 to view it, you notice now I have two columns, and now df7 is no longer a series, it's a pandas table. It's a pandas table. So I can now go ahead and I can do the sort values on this as well. But now on a table, your sort values work slightly different than a series. On a table, your sort values require an additional parameter. It requires you to specify the column or columns that you want to sort by. In this case, I want to sort by, no, not contribution account, this one, CONTB underscore receipt amount. Because now df7 is a table, if I do sort values, I must choose a column from the table. It is only because series only has one values, as many indexes as a series might have, it only has one value. So by default, those are the values that are being sorted. So now I sort this. I do it in place equals true, so it permanently changes the table. And then I do df7 dot head 5. And then you'll see the results. You see that, guys? Retired, attorney, same thing as before. Also, there's another way to do this. In my slides, I can just go ahead and use this little function right here called n_largest, and it makes my life much easier. Now, n_largest, again, you have to create the table. So this part I'll do or again. So once you create the pandas table, guys, where are you? Here we are. So this creates a series. This right here, actually I'll have to get rid of this. I don't need this anymore. This right here is going to convert this into a pandas table, right? And then I don't need to do any of this sort.head nonsense. I can just use this cool little nifty little function here called .n_largest, right? And .n_largest does exactly what it's saying. It's choosing the largest amounts, in this case 5 largest amounts of this column from this table. I run this, and look what we have. Again, retired, attorney, lawyer, etc., etc. How easy is that? So those are pretty much the 3 different ways you can answer this question. The 3 different ways you can answer this question, right? You just have to be cognizant of, again, I cannot stress this enough, you have to be cognizant of what data container you're playing with at any given moment, right? This is true for R and ABI, and this is true, obviously true in Python. Number 8. For number 8, guys, in this case, it's the bottom 5 donors. And yes, we can do it the other way as well. All right, we can do the other way as well. Or we can use the n smallest. We can use the n smallest function. Now here, notice I say, look, we can use tail 5. Why do I say we can use tail 5? Because what happens is in df7, not in this case, like if we sorted df7, right? If we sorted df7 in ascending order, then the bottom 5 actually end up being the smallest, right? The bottom 5 end up being the smallest. In this case, I can go ahead and do the same thing right here again. I can use any one of these 3 techniques. I can do them all over again. I just have to, in this case, let's just do the first one again. Or let's do this one again, the reset index. Right, in this case, Get rid of that. I reset the index. The difference here is this. The ascending equals false goes away. Ascending equals false goes away, so now it's in ascending order. And now, because it's in ascending order, if I do head 5, right, I'll get the smallest values, right? I'll get the smallest values. Notice you have, all these are all negatives. Home care director, coaching, utilities engineer, tenant relations, whatever the heck all this stuff means. All right? Or, again, I can use the n smallest. Instead of n largest, n smallest. Bam. Right? Real easy. Right? Real easy there, guys. All right, so let's see. We have now number 9. Let's see. Okay, 3, 4, 5. Okay, sweet. So we'll end at this point. Well, after this question, we'll end it. So in number 8, before I get to number 9, you notice these are negatives. Well, what if I want the values that are the 5 smallest that are not negative, right? How do I do that? Well, it's really simple, okay? Here, I show you what to do. We're going to basically do the filtering directly in DF7. We could use the LOC if we wanted to, or we could do it directly in there, right? So I'll do both ways. So I'll basically say DF7 remember, we're creating true and falses here again. DF7 DF7 anywhere where this is greater than 0. Sorry. Greater than 0. All right, so anywhere this is greater than 0, right? So now within here, because we're placing this logical, remember this logical check, if I just run this part right here, it gives me true and falses, just true and falses. When you place the true and falses within the square brackets of the data container, just like before when we're using LOC, it's only going to select the trues. So if it's only going to select the trues, out of those trues, it's only going to select the values that are positive. And now to this we'll call n smallest. Now you notice you'll get an answer back, the smallest ones that are, it's easier to see it this way, the smallest ones that are all now positive. Financial engineer, 80 cents. Corporate financial advisory, the hell does that mean? $1. Drug rep, freelance TV and film producer, hedge fund investment professional, $1. I didn't even know you could donate $1, right? That is hilarious, right? So, but another way to do it obviously is LOC. LOC would work the same way. So let me do that. And the only difference here, I just put a .loc in here, right? Same thing. Okay. So even though we don't need for this one you don't need LOC to do it because it's really straightforward. Because you're not updating any values. You're not updating any values. You're just saying, hey, just show me this, right? And that's why it worked in line 165. If we wanted to update the values when we're doing logical checks, then you need the LOC. So now this is a great place to stop. So this ends pretty much part B or part C. Yeah, this probably the videos got kind of messed up. So part B is gonna be like 10 minutes. This is gonna be like an hour and 10 minutes. Together it'll be. So this ends part C, and then we're going to finish this off in part D. All right, guys?